Okay, so let's look at the structures for the pyrimidines now. So again, these are going to be a monocyclic ring system with a six-membered ring. Okay, and so we can start by drawing our backbone. We're going to start first with uracil. Okay, so I'm going to draw my six-membered ring and then put the nitrogens in. Okay, and so this will be uracil. All right. For uracil, we have a carbonyl group here, double bond here. This is going to go to the ribose and form the glycosidic bond with the ribose sugar. Okay, there's another carbonyl group at this position, and that means there's going to be a hydrogen here. Okay. Now from uracil, it's really easy to draw thymine. So we're going to put thymine here. Okay, again, the six-membered ring, nitrogen here, another nitrogen, 2 carbons away. All right, this goes to the ribose. All right, carbonyl looks almost identical to uracil, except there's a methyl group in this position. Okay, that's the only difference. Okay, now remember when we talked in class, we were looking at biosynthesis of cytosine triphosphate from uracil. And so uracil is the precursor. Let me make that a little bit bigger. Uracil's precursor for cytosine biosynthesis. So we have a very similar structure again. So this is the ribose sugar. Let's see if we can still see that. Yep. All right. We have our nitrogens. All right. And we keep the carboxyl group here, except this carboxyl group gets replaced with an amine. Okay. Now we have a double bond here. All right. So this is cytosine. So remember, again, the biosynthesis pathway goes through biosynthesis of uracil, and then ultimately ends up forming cytosine as well. Okay. All right. And so those are your 3 pyrimidines. Again, look at the differences in the hydrogen bond donors and acceptors. For instance, between thymine and cytosine, you can compare these because these will both be in deoxy ribonucleic acids, whereas in ribonucleic acids, it'll be uracil or cytosine, right? So look at these, then, for instance, the thymine and cytosine, and note that there are differences in the hydrogen bond donors and acceptors between these 2 nucleic acids, or these 2 nitrogenous bases, which then get attached into the nucleic acids.